So, good afternoon. Thanks for making time. I know it's busy coming back from the holidays and during the revision period as well. This webinar, we're joined by Damian, the science subject lead from AQA, and he's going to be giving useful insights into the challenges students faced in the 2025 GCSE science exam series. Damian previously worked as the curriculum support manager for science. He has over 20 years of teaching experience before he joined AQA and worked across a really wide range of schools delivering support, school improvement, and training. He's also been the science consultant as part of the secondary national strategy and has extensive leadership through roles in Merseyside and Lancashire schools, and he holds an NPQH. So he's really enthusiastic about making science accessible to all students and developing skills alongside subject knowledge, and then those practicals that develop student skills and their understanding while promoting a love of science. So we're really excited that he could make time for us. Just a bit of housekeeping before we get started, before I hand the floor to him. The chat isn't active, but there is a Q&A box, which you can usually find on the right-hand side of the Zoom window, where you can submit questions or comments throughout the session, which I'll be keeping an eye on. So please do make use of that. We'll make time at the end and get to as many of those comments and questions as we can. We're also going to be recording this webinar and sending it around afterwards. So without further ado, I will hand the floor over to Damian.
Thanks very much, Constance, and good afternoon to everybody. Thank you for joining. For some of you, it might be your first day back. For some of you may have been back a week already. But the idea behind this is to give you a little bit of a high-level overview about some of the challenges that your students faced last year and how that may sort of guide you in this period as you prepare them for the summer examinations. So I've got a short presentation that will be made available to anybody that's come along. And I'll just take you through some of the key themes identified from last year, but also some of those things that come up year on year that might be a benefit for you to consider as you approach this revision and intensive period going forward. So just to start with, some of the challenges associated with this. Every year we find that students make mistakes in our exam papers. So they misread the questions, they misunderstand the questions, or they misinterpret some of the information within the question. And sometimes they don't really know what to do and don't know what the question is asking them to do. So what we're going to try and do is break that down into various areas to look at what are some of the things that you can do to support your students. So what I'm going to try and cover in this brief webinar is, first of all, some of the knowledge and application of the subject content and how that can be a barrier to students and some of the challenges associated with that. We're going to have a look at how examination technique can be improved to try and improve the quality of the answers students produce. Have a look at understanding those command words, those tricky command words, and ensuring they don't fall foul of those. How they can apply the correct mathematical skills, and then the practical skills, which also come up within our examinations. So just to give you a little bit of a highlight, though, we're going to just talk a little bit about some of the challenges from the summer series in 2025. Now, it's really important to recognise at this point that whilst it might have been an issue last year in terms of the summary feedback that we provide about our examinations, there's no indication that that may feature in this year's examination series. And one thing I should stress right at the beginning is I've not had any sight of the summer examinations in 2026, so I can't provide any insight or guidance as to what is going to be on those papers, and similarly this presentation is not about that. But what you can do is you can identify some key themes associated with those examinations, which is what we try to do every year to try and guide teachers in applying those principles when they're thinking about their teaching with their current students. So I'm just going to talk about some of the key issues associated with these papers. So in terms of sort of the key themes across all the papers that we saw students struggle with interpretation of the particular questions, but also the application questions. So applying their knowledge to those familiar and unfamiliar contexts, sometimes interpreting data, and those extended response questions in sufficient depth to actually qualify for a reasonable score in those questions. We see year on year problems with interpretation of the specific terminology or the everyday language used rather than subject-specific vocabulary, and that's across all three sciences. And we do see year on year some problems with interpreting the command words. So making sure students are familiar with what those command words are, but what the expectations from the examiners are, is really important, especially if you're looking to try and move students to the higher level or highest levels of response they can produce. Practical skills-based questions, things that are based around working scientifically, but also the required practicals, again, proved to be challenging for students overall. They failed to describe valid methods, interpret the evidence, provide a rationale behind some of the particular steps within a methodology, or understanding how they can make improvements to those practical activities. So those are sort of some general themes, and I hope you appreciate that these are themes that we have seen in previous years as well. So it could be that these skills may be a challenge for your students again this year. So if we break it down into sort of the separate subjects, so this is just looking at trilogy, so we're going to look at biology, then chemistry, then physics. So in terms of extended response, as I've already mentioned, extended response tasks are often underdeveloped. Students using vague phrasing, imprecise language. Students really struggled to explain the concepts in depth, particularly the immune response and the respiration topics. As I said about the command words, some students misinterpreted explain and evaluate, or state and describe, and because of that they failed to get perhaps those higher level responses and scores for those questions. When we're talking about the practical experiences and practical skills, when we looked at the example of, say, throwing quadrats, it was clear from some of the student responses that they either hadn't experienced that or they had some misconceptions associated with that and that particular practical skill development. When we looked at data interpretation and application, students struggled with interpreting the graphs and tables, and they can be found to be repeating information from the question stem rather than the application of it. Math skills, we've seen over the last few years an improvement generally in math skills. And again, for biology, we saw some pretty solid use of maths throughout the two papers. Where they did struggle is rearranging equations, sometimes unit conversions, and some students really struggling with their calculator use. When we looked at identifying instructions, perhaps multi-step calculations or multi-step parts of questions, they struggled missing out some of those key steps. So an example of that from the biology was the genetic diagrams, then missing out key steps, which then meant they couldn't achieve the full marks from that. If we have a look at the chemistry examples, so again, to do with the scientific terminology, we saw vague and incorrect terms as fuels instead of fossil fuels, or amount instead of yield. Perhaps more flooding rather than flooding itself, so that sort of being able to indicate whether it's more or less. We did see misunderstanding of topics such as bioleaching, phytomining, and electrolysis is always a challenge for students year on year. Questions that involve practical work usually had higher non-response rates, so that students seemed as though they were less comfortable answering these sorts of questions, or especially those about planning and interpreting investigations. So perhaps that's an area, again, that could be something that might feature in your revision programme. Low demand questions. Generally, students find our papers very accessible. We know that actually having the equation sheet is helpful, and the confidence that we saw in terms of some of the recall and the structured calculation questions was something that was really positive in terms of issues from our trilogy papers. Where they struggled is perhaps converting to standard form when they had to do the analysis of graphs, etc. When you look at the demand of the high demand questions or the challenges associated with that, again, extended response questions, we saw a lot of level 1 responses rather than level 2s and level 3 because of imprecise scientific language, or they didn't use the right comparative terminology, so they weren't able to make comparisons clearly between two sets of information. Again, talking about math skills, they struggled with the unit conversions, they struggle with the use of standard form, especially when we're talking about it in terms of unfamiliar context. And unfortunately, a recurring problem, because this was a problem both in 2024, but also in 2025, was confusion about the gas tests. So again, maybe that's something that you might consider revisiting. And finally, when we look at physics, just some key things came out of physics. We did notice some gaps in some fundamental knowledge, so things to do with radioactivity, circuitry, circuit diagrams and circuit diagram construction, refraction, and particle models were areas that students struggled with. So perhaps those are gaps in terms of student knowledge. Maybe that's something you can look at in terms of a focus for your revision. You might choose not to do that. As I said, I can't guarantee what's going to be on those papers, so please don't take what I'm saying as read that it's going to appear on the examinations, but these are the themes that came out of last year. When we're talking about paper accessibility, the equation sheet we think has actually enabled accessibility for students on the physics papers, reducing the cognitive load. But actually what's that meant is that some students have relied on it rather than perhaps the application of the scientific understanding. So maybe it's put them into a false sense of security. So we did see students making what we thought were relatively simple errors. So having a go at the questions, but making some simple errors associated with using the equation sheet successfully. So making sure your students know how to use it correctly is something that would be a benefit. Across the physics papers, we do see structured calculations well attempted, rearranging equations, using the calculator correctly. Some students did make mistakes using the calculator correctly. Again, we had problems with unit conversions and interpreting some key terms like deceleration. And anything that involved putting more than one set of numbers through formula were less successful when they were answered. Practical method questions, unfortunately, the multi-step calculations and the extended response questions, students failed to specify the correct equipment, or they didn't link the measurements to the correct equipment or the correct procedure. And there was often gaps or mistakes within the procedures. So again, when you're looking at those required practicals, having a look at the organization of those steps, the reason for those steps, but also that sequencing is something that could be revisited. I've already mentioned about the scientific understanding of terminology. That's still a barrier. People think using sort of terms like braking faster, and then confusion between thinking distance, stopping distance, and some students using optical density. So that's possibly influenced, we think, by possibly AI use it for revision rather than coming directly from revision guides or our specification. And as always, unfortunately, some students fail to read the question correctly, especially the evaluation style questions. So that gives you sort of an overview of some of the key sort of topic-based issues associated with our examinations. But it's not just about identifying that content and perhaps even predicting that content. What I also wanted to identify is some other errors that are associated with our examinations and provide you with maybe some tips to try and cover with your students. So these are written as though they might be of benefit and use to share these with your students. So we're going to have a look at, first of all, box ticking. If a student wants to change their mind, they can cross an answer out, just making sure it's clear which one they want to be marked as the correct answer. You can see here an answer's been given and then crossed out, but actually they've sort of not correctly then identified the alternative answer they want to. If I share another example, this was a question from 2025. It was a standard demand question, but we got a high number of students that didn't give two answers. So is it because they hadn't read the question correctly? So making sure you're clear about what's being asked of you. So from a statistical point of view, 72% of students got 1 mark correct, but only 22% got both marks for a multiple choice question. And there were a significant number of students that only gave one answer. Now, if a student gives 2 answers, but they tick 3 boxes, so 2 of those are correct and 1 is wrong, unfortunately, the list rule then applies. So it's important that students only tick the right amount of boxes. So here, these are the 2 correct answers. So a little top tip for your students is only tick as many boxes as the question asks for. If too many or not enough boxes are ticked, then you're not going to achieve full marks. If we look at making connections, so again, a multiple choice question, this time the expectation is to draw one line. Again, if a student wants to change their mind, they can cross the answer out and change and mark the one they want answered. One thing that we see year on year is students failing to cross out their alternative answer. We see it more often that they cross it out when they're doing the multiple choice tick boxes. They fail to cross it out effectively using the lines. So they've got to make sure they only draw one line per box. Any extra lines will cancel out a correct line unless it's really clear which one is the incorrect one and crossed out. So the examiners won't know which is the answers to be marked, and so then the list rule applies. This, this question here again from 2025, you can see 2 lines are drawn from the middle box, and so that student isn't able to achieve the correct answer. So the top tip here, only draw 1 line per box. We'll never ask you to draw more than 1 line per box. So if you do draw more than 1 line and you're not crossed it out effectively, you're not going to be able to achieve full marks. We see a lot of this happening within our examinations. So if I'm going to highlight, so if you look at this first section here, because the blocks are made of magnetic material and the crane has a strong magnet on it. But if you look at the box next to it and the diagram associated with this question, it's clearly laid out. It says box made out of magnetic materials. So all they're doing is they're simply repeating the label on the diagram. So anything from the stem of the question isn't credit worthy. The student identifies that the switch turns on the magnet, picks up the block, but there's no real linking of ideas. Student has to add something extra new to their answer to show an understanding of what happens. Okay, as a result, this was only worth 2 marks of the 4 marks that was possible for the 6 marks that was possible for the extended response. This was quite a poor or weak answer. So just a reminder, repeating information from the question stem isn't credit worthy. Diagrams and labels are often included to trigger our students' memory, but answers should always demonstrate an understanding of what's been asked or an ability to link those ideas together. So the top tip there is information in the question is there to help you, but don't waste time repeating that question or that information. It should include your own knowledge when answering the question. Now, clarity of language I mentioned before, and it's really important that students are clear on the language they use. Students often give answers that aren't clearly linked to the question or where the meaning isn't clear. So if you look at that first example, 6.2, amount is insufficient for the mark, so it scored no marks. Examiners were looking for the terms concentration of the acid and mass of the metal. Vague words such as amount rather than mass or volume or concentration are common errors we see year on year. If you look at the second example, 5.3, if the student has simply written down it would have broken down, it would have gained the mark, as it is clearly referencing insulin. However, they've then continued the sentence by writing into protease. So it cannot score the mark because that's incorrect science. And just a reminder about some of the principles associated with marking. So you'll see at the beginning of our mark schemes, information for examiners, and it talks in 3.4 section about interpreting the word it. So it's really important that you know what to mark correctly for it. So answers usually should only be given credit only if it's clear that the it refers to the correct subject. So top tip, try to use the subject-specific science terms. Read the answer back to check the answer has been clearly linked to the question. Make sure there's no contradictions, and you should avoid using it. It is not particularly helpful for students to use. So, looking on to the command words. So making sure students understand the expectations of the command words and what is appropriate and what is credit-worthy. So we'll have a look at this question here. So explain why aluminium window frames do not corrode after they're made. So it's an explain. Okay. Now the description, a description or an explanation. For a describe, students may be asked to recall some facts, events, or process in an accurate way. For an explanation, students should make clear or state the reasons for something happening. Now, in this example, you can see aluminium is protected. So they score 1 mark for aluminium is protected, but they've not explained why. And so they fail to get the 2 marks that this is awarded. If we look at this example, 4.3, here, explain why solid C separated from mixture C and D. So the filter funnel allowed the solution to run into the beaker and C stayed in the funnel as it was a solid. So that's not an explanation. It's a description. They've stated what happened. They didn't explain why separation occurred. They didn't talk about solubility. Now, this example was taken from the report of the exams, and actually learners did find this question particularly difficult and didn't really go on and explain successfully why solid C separated from the mixture of C and D. And many of the incorrect answers focused on how filtration sort of works, etc., describing large particles getting trapped in the paper, etc. So make sure your students are familiar with what's expected of a describe and explain question. Just another example here, this one from 2024. They've said, describe how air pressure in the container changed as the temperature decreased and then increased. So it's a description they're looking for. A sizable proportion of learners appeared to not read the question correctly and instead went on to describing how the pressure changed and gave explanations of why the pressure changed. In doing so, many of them didn't include a description of how the pressure was affected and so scored no marks. So in an explain question, the answer shouldn't just be a list of reasons or points. Points to the answer must be linked coherently together and logically, using words such as so or therefore, because, due to, since. These are all good connecting words. Another point for these types of questions is look how many marks the question is worth. It's worth trying to think of that many facts or statements or points that you're going to make. The reason needs to get, so your answer needs to, or the student's answer needs to give a reason why something is happening and use words like so and because to link their answer to the reason they're stating. So then we go on to the command word compare. So we're looking for a comparison. So this question from 2024, standard demand questions. A lot of students wrote quite a lot for their answers, but unfortunately, very little was creditworthy. We saw some incorrect science, incorrect use of basic terminology, atoms, molecules, not used correctly. A quarter of students gained 1 mark or more, but there were very few level 2 answers. Now, this was a leveled response question worth 6 marks, but it only had 2 levels of response, level 1 and level 2. The problems associated with this were that actually lots of students didn't make a comparison. So here's an example of a student response. So you can see that they've made several creditworthy statements. So you can see they've made references to the different types of forces and the types of bonding. They've also made reference to perhaps the magnitudes that you can see, simple, weak, strong. So you might look at it and think, actually, this is a really high level response. However, no attempt has been made to compare the two. And as a result, no comparisons have been made. So this answer has been capped at level 1. So gained the maximum 3 marks that was possible within that band. So missing those words, those comparison words like however, or similarly, or in contrast, or ER words, for instance, that makes a comparison between them, means that this unfortunately isn't achieving the highest levels of an extended response. So a top tip associated with these is comparative statements must be made, not just simply a description. So consider using those ER words to emphasize the comparison, smaller, greater, lower, faster, etc. So evaluate. A key problem we see is students often failing the last part to include a judgment. So I just want to stop a second because I do see questions come in, and just because it's pertinent at the time, I will go back one if you're okay. So thank you, Darren. So there is not a definite best way of structuring the responses, but you can put it into a table, and a table is quite helpful to do a comparison because you can have comparative points on the same row in a table. And so if you make a statement on one, you've got a table and comparing to the opposite side, you're comparing one side with the other. So it's much easier to make a comparison because you can see that they've been linked directly together, those two statements, if it's in a table. If you're just writing it as prose, then it's easier to make the comparison in the same sentence or consecutive sentences. If you do a statement about one and then a full statement about the other, it's much more difficult to actually to join up how the comparison's been made. So if you're doing comparisons, so what I would encourage you or encourage your students to do is either to do it as a table or do it per point that you're going to make. So compare a point, stating what one does, what the other does, then move on to the next point, stating what one does and what the other does. That's how I would structure it, either as a table or in that prose form like that. I hope that helps. So this evaluate question. So you can see in this example 5.3, there's not been any judgment made and no comparison has been made. To access the level 2, learners needed to provide a judgment supported by appropriate comparisons and links, and also simply repeating data from the table goes back to what I said right at the beginning, which is students won't get marked for just regurgitating things from the question stem or data from the table. They had to do something with it. So if you're looking at evaluate questions, you need to be able to look at making sure it includes that judgment at the end of it. So a top tip associated with this, use the information supplied as well as your own knowledge and understanding to consider the evidence for or against, but make a judgment. At the end of it, you must think, I think this because I think this is better, this is worse, this is cheaper, this is more expensive. This is the value for money. You make a judgment at that point, and that's critical for these evaluate questions. So it's similar to a comparison, but you're making a judgment at the end of it. So did mention also that math skills, and we mentioned a number of errors that are associated with math skills that students exhibit within these examinations. So you can see this example, 2.4, okay, the equation's been given. This is a low demand question. Students use the correct numbers, but they've not used the equation given. They've then gone on to use the calculator incorrectly, and their final answer was also wrong. So scored 0 marks. Okay, so get your students to read the question carefully. A number of students year on year make simple mistakes like this, misreading the question or misusing equations that are given. So read the question carefully, use the equation as it's been given, or use the correct equation from the equation sheet. Use the numbers in the question, check that the answer makes sense. Now that last step, checking the answer makes sense, that sense check, is often missed. And it might be missed because the students, stressed. It might be that they want to get through to complete the paper, etc. But that's a really valuable step. Do that sense check. Is it what I would expected it to be? Is the number, what I sort of approximated it to be? That's a really useful stop and check for students. So I would encourage you to encourage your students to do that. If we look at this, students often make mistakes in calculations, as we mentioned, sometimes not converting units correctly or converting them when they shouldn't do, misreading the units or missing out steps. So if we look at this first example, 6.4, students correctly substituted, but then failed to convert the kilowatts. So scored 2 of the 3 marks that were available. And that was seen, we've also seen, unnecessary unit conversions because they misunderstood the equation. If you look at this 5.3, students misunderstood meters per second squared as the unit for acceleration, so they've incorrectly then squared the number 11. Okay, they then carried out an additional calculation by, and used that figure in their final answer. So take care is the top tip with regard to these. Make sure your students know how to convert between those common units such as kilograms, grams, etc. Useful to learn those common prefixes, mega, kilo, milli, micro, nano, etc. And understand the difference between meters per second and meters per second squared. It's really important. Graph skills, we have seen some improvements in graph skills over the last few years, but there are still a number of errors that we see year on year. If you look at this example, again, this one was from 2025. 55% students got full 3 marks on this, marking that the most common issue that we saw in this type of question was actually selecting the appropriate scale. So in this instance, unfortunately, it's less than half the size of the graph paper. So they weren't awarded for choosing a correct scale. Okay, they did get the bars plotted correctly for their scale, and then they labelled them sufficiently. And so this person scored 2 of the 3 marks. Common mistakes are non-linear scales, 5, 10, 20, or unsuitable sizing for those. And sometimes the intervals between the bars not being correct, so not using the grid lines correctly, even if they had correctly sequenced the numbers. We also saw a large number of students using incorrect graph types, such as scatter graphs or line graphs when a bar chart is what was required. So again, ensure your students take care with the graph they select they're going to do, and think about the principles of why you should use what graph. So if you have a look at this example, this was one that we saw. Clearly, you should be able to see from the points plotted that this should have been a line of best fit. Okay, dots and crosses can be used, but we find that dots are often hidden by any line, so crosses are probably better for examiners to mark. So again, encouraging your students to use crosses rather than dots might be better. So encourage them to use as much of the graph paper as possible. Scale is nice and appropriate to be seen and clearly plotted. Make sure those lines are smooth. Don't, whether it's a straight line smooth or a curve that's smooth, make sure it's not jagged or it's not gone over several times. So some top tips associated with graph work. So at least half the graph paper to be used. Plot the points correctly. Take care to understand the scale. So if you're plotting that scale, or if the scale's been given to you, making sure, use a pencil. HB can be used to draw a graph, and mistakes can be rubbed out. Look at the pattern of the data to decide if it should be a curve or a straight line. And I noticed from Claudia, there's a question, would they be penalised for using a pen? No, they wouldn't. The only reason they'd be penalised is if their line is out of tolerance. Now, some people think a pen is better because it shows up clearer for the scanning. Pencil does show up fine for scanning, so please don't be worried that you need to use a pen to show, so otherwise it's not going to show up. If they're using a proper HB pencil, that's fine. I know there are some grades of drawing pencils which are a lot fainter. We wouldn't encourage them to use that, but I'd always encourage to use a pencil over a pen because of the ability to rub it out. The disadvantages of using pen is if they make any mistakes, they can't correct it, and it's far more difficult. Even if you cross out a pen line, it's going to get in the way of other plotted points or other drawn lines. So I would always encourage students to use a pencil. Practical skills. So that we saw some errors associated with the practical skills. So these were questions that were from the foundation tier and from the higher tier that students didn't answer well because they didn't understand the key terms. So these questions require students to know that disability language associated with variables, with practical work, understanding risks, control, accuracy and reliability. Sorry, Darren, yes, you're correct. The tolerance is plus or minus half a small square. And that's to do with graphs. Apologies, I was just seeing a question that had just come in. So we do ask quite a number of extended response questions associated with our required practicals. This is an example that came from a higher tier. Students mostly written a description of the equipment setup. There's nothing of relevance about a method here. And so unfortunately, the student scored no marks for this. So it's important that they understand the command word, understand what is expected. This particular question that came from 2024 is based on the required practical activity 20, the ripple tank. This is to do with vibration of a string, but we saw a large number that wrote about ripple tanks. So it comes required practical 20, which is the same required practical as the ripple tank, but it was clear that students had more experience of the ripple tank than perhaps this example. So make sure if you're looking at all of the required practicals as part of your revision, making sure students are familiar with all types. The other thing to mention about the extended response questions is just what we mean by a valid outcome. It comes up time and time again. What's the requirement needed for a valid outcome? So it's really important that you understand about the steps that are going to get to a set of data, which is going to prove or disprove what you're trying to find out. That's the definition of that valid outcome. So another example here, especially to do with valid outcomes. So describe a method student could use to obtain the results in table 2. And students struggled with this question. It proved challenging. 21% of learners not attempting it, and 43% scoring 0 marks on this particular question. What we're looking for a valid method, okay, allows the effect of the independent variable to be observed in the dependent variable, changing only the independent variable, measuring the dependent variable, a range of values being collected, and allows a conclusion to be drawn that meets the aim of that experiment. So just some top tips associated with this. Make sure you know the meanings of those key terms, those working scientifically terms: dependent, independent, control variables, accuracy. Make sure, remember the required practicals you've seen. Maybe they look slightly different in the examination. Don't worry about that though, because it's the same skills that are being assessed. Make sure you understand what they understand what's meant by a valid outcome, and have they included all the steps necessary to get to that point. And the final thing I'm just going to mention about extended response questions. So you can see here, students drawing a diagram. You may include a labeled diagram to assist you in your answers. And that's absolutely fine. You can include diagrams, even if it doesn't state. You may include a labeled diagram. If you think it's going to help you answer those questions, you can include a diagram to support your answer. So in this instance, you can see the students clearly labelled the diagram, followed by some descriptive prose. They actually gained 5 of the 6 marks that were available for this extended response. And a lot of those marks came from that clearly labelled diagram, because it's clear what the arrangement of the apparatus is, it's clear what the normal is, what the angles are to measure. The only important thing that's missing really is about the range and the intervals used when they're changing the angle of incidence. But they don't have to be written like that. You can also put tables in for extended response questions. So when we talked about compare questions, we did say that they could write it in table form, etc. And another example is they can write it as a step of bullet points. So any of those are perfectly valid ways of answering these style questions. It doesn't have to be long extended prose. It can be bullet points. It can be a numbered list. It can be a diagram. It can be a table. Don't feel as though you've got to use up all the lines either. That's really sort of a maximum amount. So some top tips associated with this: try not to stress about these types of questions. There's no one right answer to this. You don't need to fill up all the answer lines. Answers can be short and to the point. You can use labeled diagrams, tables, bulleted lists to help you create your answer. The key thing that I want to try and stress for you and your students is get them to have a go. With these questions, any relevant information is likely to score a mark. And remember, every mark counts. So that's the end of my sort of presentation. I do want to say that I'm going to be available for some questions. The aim of AQA is never to let a learner down, and so that's what we try and aim to do with our assessments. So what we tried to cover in this brief webinar is some of that key knowledge and application that students struggle with, some ideas about how you can improve students' examination technique, their understanding of those command words, applying the correct mathematical skills and practical skills.
Fantastic. Thank you so much.
So Claudia's asked, what if students compare questions as a table? That's absolutely fine. They can draw a table on those lines, and that's a good comparison.
Great. I'm just going to leave a little bit of time for anyone who has any other questions to go ahead and think about them and type them into the QA. Really, really interesting. I was thinking about that point you made about how the physics equation sheet has improved accessibility, but is perhaps sometimes a bit of a handicap. And I think we've seen that in our own data, looking at students' answers from last year, picking the right equation, not even recalling it or applying it, is a pretty big first hurdle for a lot of students.
Mhm.
And if they can't pick the right one, then even applying it is a
Yes,
much bigger step forward.
yes.
Yeah.
Did you want to
And
mention about the command words as well,
oh,
Constance?
yeah. If you think your students are struggling with those command words, and we have some questions that can give you a real quick check to see if they understand what each of those command words means and what it's expecting them to do. Those are really easy if you're on Educake and you go to set a quiz. All you need to do is look for the exam preparation unit, and you can find a collection of questions in there. And we're also working on, in the next couple months, we'll be adding some questions that help students know where they can avoid losing some of those easy marks. So things like making sure that they are providing their answer in the correct format. If it's asked for standard form, put it in the correct standard form. Showing their working so that even if they do make one of those calculation errors, if they type it into a calculator wrong, they can still get points for the method portion of their working. So we've got a collection of those that are targeting very specific points that they can not miss, that hopefully help some of the things that Damian's brought up.
Does anybody have any other questions that they want answering?
We can wait as they type some in. We've got a few questions that we gathered beforehand.
Yeah.
Um, do you have any tips when it comes to deciding which tier to enter students for? Is there anything you'd suggest teachers look at?
Yeah, so one of the things that obviously is really important at this time is making that final judgment about what tier of entry. Um, the tier of entry decision is got to be about how the students are performing on those standard demand questions. So they might ace the low demand questions on the foundation tier, but if they are struggling with those standard demand questions, then I would suggest that the higher tier paper is not going to be accessible because it's a much smaller proportion of questions that are standard demand, and you then move on to the higher demand questions. Yes, it's a lower grade boundary to achieve on the higher tier paper, but it's much more challenging in terms of the degree of difficulty of those questions. So remember, the overlap is only 30% of common questions, 40% overall that are set at standard demand, and then the 60% at high demand for the higher tier. So if you look at your students and they can't do some of those standard demand skills, so they can't rearrange equations effectively, they can't place answers in standard form, they don't have access to some of that target language, they don't really know how to spot anomalies in graphs, they're not able to use those key scientific terms, then they are going to struggle on the higher tier paper. And those are the decisions I would think about when you're looking at that tier of entry. And you
Great.
can do changes to your tier of entry up until tomorrow, free of charge. So 21st of April, I think after that, any late changes to tiers of entries does incur a fee. But you have until the end of play tomorrow, as far as I'm aware, that you can still make changes to tier of entry. So even though we're quite late in the day, you can still make changes with no cost effect to your school.
Good to know. I think we have time for one more question. I see one from Darren in the Q&A. Do you have any tips for those 6-mark multi-step equations?
So this is a real challenge. I think one of the things that we see is obviously you're looking about two equations. So how they take an answer from one equation and then input it into the next equation. So one of the key things is, first of all, can they identify the two steps that are necessary for multi-step calculation? So the first thing is trying to think about what's the requirement, what data have they got within the question, select the equation from that, and then one of those key terms is what they're then feeding into selecting the next equation from. So looking at what's required from the question, but looking at the data that is given in the question should allow you to select those two correct equations, first of all. So that's the critical first step for me. Then what you've got to do is take them through the stages of that first calculation. So making sure that they arrange that equation correctly. If it needs rearranging or if there's any unit conversions, they do that. And sequentially lay that out on your answer line as you can, and then move on to the second calculation. most of these questions will have some sort of error carried forward judgment with it. So if a step is missed, it doesn't mean that it's necessarily going to negate their ability to answer all the rest of that question. So they might have some alternative answers that are credited in the mark scheme. So what I would say is, so that's one of the things in terms of how you structure it with your students. And I would try and encourage your students to be resilient and power on through, because the chances are if they do more and more of those steps, even if they've got an error within it, they might be able to get more of that compensatory marks.
Great. I think that is probably time for us. So just thank you so much for joining us and for participating, especially those of you who had questions. Damien, thanks so much for putting this together and sharing your insights and some useful information. As a reminder, we are recording the session and we'll be emailing it out, so you can watch your inbox for that. And please feel free to share it on with any colleagues
Yeah.
who couldn't attend.
And the last thing, just to say, if you ever need to get in contact with AQA, the details are going to be on this PowerPoint, but are on the screen at the moment.
Great. And before you sign off, I have a really quick favor to ask. So to help us to continue to host and facilitate sessions like this, to have great speakers like Damien on, we need some input from you. So there's going to be a very short survey in your browser directly after the webinar. We'd be really, really grateful if you could take a second to just pop in your feedback. And that's it from us. So thank you again. I hope you have a really nice evening and a great rest of your week.
Yeah.
Good luck with your revision.
Thank you very much and good luck.